the insides don't match. Huh, but I've got a fix for that. I've got a formula for cosine 2x. That should be ringing bells. If those insides don't match, make them match. So I have my choice, which there's a bunch of formulas for these, but since I don't want to memorize all of them, I always just start with that one. And the other ones are easily derived. Like right now, I would prefer to have this whole thing in terms of just either sine or cosine, not both. So I'll go ahead and change this to 1 minus sine squared x. And that's where that other version of the cosine 2x formula comes from, just 1 minus 2 sine squared x. So we'll go ahead and drop that guy down. And now again, we got powers that are bigger than 1, so we set everything equal to 0 and cross our fingers that it factors. There we go. And we will attempt to factor this guy. So we get 2 sine x, 1 and a 1. Let's see. Yep, it'll work. Excellent. So if this times this equals 0, then one of these has to equal 0. And I just love how everything builds. Like everything you've learned in high school has built up to this moment. You're just moving and factoring, and now you're factoring this, and yeah, it all comes together. Anyway, so now you're just undoing this last little step, just an extra step, undoing the sine function with an inverse sine without the restrictions. So you're wondering what angle gives me a sine value of 1/2. Where on my unit circle is my y value 1/2, and that's at pi 6 and 5 pi 6. And then here, where on my unit circle is the sine, what angle gives me a sine of -1, and that's down at 3 pi halves. So that would be it if you were just going from 0 to 2 pi, but if we wanted to give them all, I could take that 3 pi halves and add 2 pi k as many times as I'd like, and these guys I would also add 2 pi k 2 pi as many times as I like, so 2 pi k times. There's no special things for this one because the pi 6 and the 5 pi 6, they're not perfectly spaced. I couldn't add this and then add that again, doesn't work. And then there's just one of these, so that is all for that one. Woohoo!